General circulation of the atmosphere. The circulation of wind in the atmosphere is driven by the rotation of the Earth and the incoming energy from the sun. Wind circulates in each hemisphere in 3 distinct cells, which help transport energy and heat from the equator to the poles. The winds are driven by energy from the sun at the surface as warm air rises and colder air sinks. The circulation cell closest to the equator is called the Hadley cell. The Hadley cell involves air rising near the equator, flowing towards the north and the south poles, returning to the surface of the Earth in the south. Then we have the Faro cells. Air flows poleward and eastward near the surface of the equatorward and westward at high altitudes. This movement is the reserves of the airflow in the Hadley cells. The smallest and the weakest cells are the polar cells, which extend from 60 to 70 degrees north and south to the poles. Air in these cells sinks over the highest latitudes and flows out towards the lower latitudes at the surface. The westerlies winds, they are prevailing winds from the west towards the east. In the middle latitudes between 30 and 60 degrees latitude, these originate from high pressure areas in the horse latitudes and trend towards the poles and steer cyclones in the general manner. Okay, trade winds. In the northern hemisphere, warm air around the equator rises and flows north towards the poles. As the air moves away from the equator, the Coriolis effect deflects it towards the right. The Coriolis effect describes the pattern of deflection taken by objects not firmly connected to the ground as they travel long distances and move around and above the Earth. The Coriolis effect is responsible for many large-scale weather patterns.